days. It was a busy week. Let's do better now. Okay, you're given a string text. You should split it to k substrings such that subtext ith is a non-empty string. Okay. So we have text, and each should be k integer. Concatenation of all substring is equal to text. Okay. Subtext ith is okay. I'm not getting this yet, but I'm getting that we need to return the integer. Oh, we are actually not given k. We need to return the k. Okay. Subtext, oh, I is a substring. Oh, Palindrome decomposition. I see. So we are splitting it in chunks. And we are comparing chunks from the ends. Okay. So tests and challenges. I see one of the challenges is that we are comparing things by chunks. Also, can it be that chunk, like the number of chunks is an odd number? What do we do with the chunk in the middle? Let's assume that it can be so. Let's the challenge here is that of an comparison for each chunk. Okay, so for example, ABC, DF, ABC. So here it's 3, right? Because sorry, I haven't slept well today. Because here we can split it like this. And this chunk is equal to this one, and this one in the middle is equal to itself. I'm guessing, right? So yeah, kinda we always and we need to return the largest possible value of k. That's interesting, because there is a kind of a greedy approach here. Yeah, let's think about solutions. Greedy. So always need to create the smallest possible chunks. So the thing is that we always can create a K1. We just have the whole text together. Okay. So let's here, for example, right? Let's also do something like A, B, C, G, A, B, C, B, A. So here it will be A, B, C, G, A, B, C, B, A, right? So the chunks will be 1, 2, 3, 4, 5, 6, 7, 8, 9. So the idea here is if you can match a chunk from here to chunk from here, then you just match it and you are done. If you cannot match those, you have to increase it. You have to increase it further and further and further until you converge in the center, and then you cannot increase it any further. So basically we try to match elements, and we try to match the chunks. And the only issue is that, for example, if we try to match chunks that are longer, I have no idea how to do that, because how to do that in O1, that is. Okay, so challenges. How to do this in O1? Okay, first of all, the brute force approach, right? Brute force approach will be at most O(n squared. Brute force, where n equals, will it be O(n squared? Yes, it will. Where n is the length of text. And then to do better, we need to do some clever hashing in such a way that we are also preserve ordering and can add letters from both ends, because we want to move from left to right here and from right to left here, and create such a hash that hash of this will be equal to hash of this if we start from two different directions. Otherwise, we will have to like select m letters, and then for this chunk of length m, compare whether these are the same or not the same chunks, and increase this slowly. And can we do better? So without hashing, can we do better? I think there can be also optimization algorithms. Like, for example, we can store all the places where we know what this chunk will start with, right? And we know all the places for, like, it starts with A, so we also know all the other A's in this text. And we just try to match it with all the chunks starting with the same letter. But I think you can create some counterexample that would still make it off and squared, even though this will be probably a faster algorithm. So how do we do this hashing? So it's kind of like we can create an integer that, and for this integer we will be representing like letters on the order of like we will need to use 26th power. That's what I'm trying to do, right? Like we have binary or decimal numbers, and we can also have like the numbers of 26 elements. I'm also trying to think about Knut-Morris-Pratt algorithm, whether it can be used here. We don't only know what the sequence should start with, we also know what the sequence should end with. So we can decrease the amount of things that we need to check. Okay, so let's think about A, B, C. So A is 26 to the power of 1. B is 26 to the power of 2. We can also try to remove all the instances that are definitely not working, and it will be a faster algorithm. So, for example, we can just create a list, create a counter, and while we don't have the same counters, we are sure that this string cannot be matched, right? So if we have different number of different letters, then the string will not be working. Yeah, it's like this hashing algorithm that I cannot figure out right now. Yeah, I think let's just create a counter, and it will be of 26 to compare to counters, unless we want to do something like not a counter, but a binary number that tracks whether we have some specific letter there or not. But it will not be processing duplicates well. Okay, so let's just try to do it with the brute force, but optimized brute force, so that we are not always calculating everything. ij will be equal to this and length of text -1. K is equal to 0. Left, right will be equal counter, counter. So while I is smaller than j, what do? We do left text I plus equal 1 and right text j plus or equal 1. So we also need to store right, okay. And let's also have something like L and R, which will be also L and length of text, right? So can it be 1? Okay, this is fine. Length of text, yeah. Okay, so we do that if left equals right. We check and text starting L and up to I plus 1 equals text starting at J and up to R. We do what? K plus or equals 2. I think we will just start with 1 as the default value for the center. Or no, we cannot do that, right? K equal to 0. Yeah, we need to process odd and even cases separately, because we can also have something like A, B, A. It will be 6. Okay, so if that's the case, then we do this, and now L equals I plus 1, R equals J. Okay. And then we do I plus equals 1, J minus equals 1. And if I plus equals J, K plus equals 1. Or it means that like our left and right parts are non-empty, so we couldn't find a match. Then just everything will be combined as one element. Okay, and return K. Okay, nice. I did it on the first try. I spent 22 minutes. Obviously, this is not a very efficient algorithm, but it's reasonably efficient. But there will be something. Oh, they're just modifying those chunks. It's interesting. Okay, yeah, that's actually easier than what I was doing. I didn't want to do that because you would have to compare those left to right each time, and it should be of m operations, of n, and it will give us n squared. But okay, I digress. It's an efficient solution, it looks like. And it looks like there is no like clever trick on how this can work otherwise. Overall nice. I obviously also didn't like create the tests, which is not good. I should have done this, but maybe some other time. Okay, yeah, I'm stopping right now. Thank you everyone.